Welcome to The Explainer. Today, we are diving straight into a fascinating medical mystery. We're looking at a high-stakes paradox in clinical data, specifically surrounding snakebite survival. And to figure this out, we're going to explore a really cutting-edge approach to reading medical evidence called the Brown's Stage 5 framework. Let's get right into it. All right, let's kick things off with a question that feels like it should have an incredibly obvious answer. Does snake antivenom actually prevent death? I mean, if you get bitten by a venomous snake, common sense tells you that you absolutely need antivenom to survive, right? It is the definitive treatment. But when we actually look at the data, when we look at the highest tiers of clinical evidence, what do you think it says? Well, get ready for some instant cognitive dissonance. If you look at systematic reviews, which are widely considered the absolute gold standard of medical evidence, the certainty of evidence for a mortality benefit from antivenom is graded as low to very low. Yeah, you heard that right. The highest tier of evidence basically says we have very little certainty that antivenom actually saves lives. So what's going on here? How can a life-saving intervention have such low evidence of actually working? The culprit here is actually a major methodological flaw in modern research. You see, standard meta-analyses act kind of like a giant blender. They pull all the data together to force a consensus. But honestly, nobody wants a data smoothie that just erases all the critical individual flavors. By averaging out wildly different clinical scenarios, you lose all the essential details. The alternative to this is evidence mapping. Instead of blending everything together, we segregate the data by its evidence tier. We map the actual shape of the evidence to see exactly where the signal is coming from, rather than just washing it all out in one big average. So, to understand this antivenom paradox, researchers put together a 17-paper corpus that spans the entire evidence pyramid on snakebites. Think of it as a ladder. Step 1, at the base, you have your case reports. Step 2, observational studies. Step 3, randomized controlled trials, or RCTs. And finally, Step 4, at the very peak, systematic reviews and meta-analyses. Instead of pooling all of these together statistically across the tiers, which as we just saw completely distorts reality, the goal here is to process each paper strictly within its own specific tier. And that brings us to the star of today's show, Brown's Stage 5. This is an AI-augmented clinical reasoning framework, but it doesn't just act like a calculator spitting out averages. It acts a lot more like a Socratic attending physician. It's designed specifically to perform this evidence mapping. It synthesizes the literature by mapping the trajectories of the evidence, deliberately avoiding that trap of inappropriately pooling different tiers of data together. It really wants to understand the structure of the evidence, not just the mathematical mean. To actually execute this, Brown's segregates the snakebite data by processing it through distinct, tier-specific modules. It's like sorting mail into the right boxes. Module A is completely dedicated to the 12 case reports. These are your single patient narratives. Module E handles the 2 RCTs, dealing only with broad group summaries rather than individual patients. And Module F is strictly for systematic reviews, which encompasses 69 study-level units. By keeping these modules separate, Brown's ensures that a single patient's tragic, nuanced outcome isn't just statistically drowned out by a massive, but maybe only loosely related observational study. All right, so when we run the RCT tier, that's Module E, through this system to look for a mortality benefit, we hit a massive roadblock. 0. That is the exact number of randomized controlled trials in this corpus that ethically withheld antivenom from a control group to measure if the treatment actually prevents death. Literally, 0. Let's just pause for a second and let the gravity of this sink in. Listen to this quote. A randomized controlled trial that withheld antivenom from envenomed patients in order to test its mortality benefit would be unethical to run. This right here perfectly illustrates the heart of our paradox. The highest tier of medical evidence, the RCT, completely lacks the mortality signal because it is quite literally impossible to ethically test it. You can't just take a group of envenomed patients, give half of them a placebo, and sit back to watch who survives. That trial will never, ever exist. Because of that, the top of the pyramid is perpetually blind to this specific data. So if the RCTs can't tell us if antivenom saves lives, where does the signal actually live? Well, it lives at the base of the pyramid. It's in the observational tier and those individual case reports. When Brown's maps this tier out, these recurring outlier patterns start to emerge that pooled averages would have just completely erased. We see patterns of delayed first-line care, often because a patient has to travel huge distances, sometimes to rural traditional healers instead of a hospital. We see delayed secondary clinical events happening days after the initial bite. And we see regional venom pool mismatches. These single cases, these individual stories, hold all the vital mortality and severity data. Let's actually look at a real-world example here. Case 8 gives us a really natural comparison of two patients who were bitten by the exact same species of snake, the Russell's viper, in the exact same region. Both of them took a detour to traditional healers, but their paths diverged on one crucial variable: the time to first antivenom. The patient who had an 18-hour delay spent 7 days in the hospital. The patient with a 58-hour delay, they spent 26 days in the hospital and required mechanical ventilation. This stark contrast perfectly zeroes in on early antivenom administration as the dominant hub governing how severe the outcome is going to be. You completely lose this incredible narrative if you just average their two outcomes together. And this is where case reports surface data that fundamentally challenges the generalized rules. Take the absolutely tragic trajectory of case 12. This was a single patient bitten by a saw-scaled viper, specifically the subspecies Echis carnatus suturci. This patient was given a staggering 65 vials of antivenom, 65, and they still died from multi-organ failure. Why? Because of a regional venom mismatch. The Indian polyvalent antivenom they used just didn't cover that specific subspecies. If you throw this into a meta-analysis blender, it just looks like a generic antivenom failure. But by mapping the evidence, we clearly see that the dose isn't the bottleneck here, venom mismatch is the bottleneck. Now, what happens when you just ignore all these granular details and jump straight back to the top of the pyramid? Well, in a meta-analysis known as Case 17, the statistical heterogeneity, which is basically just a fancy word for inconsistency, was high. But look closely at how it breaks down. If you only look at Australian snakes, heterogeneity is 0%. But if you group Asian snakes, it spikes to 88%. Why? Because Australian elapids and Asian vipers have mechanistically completely different venoms. It's like comparing apples to oranges. Actually, scratch that. It's more like comparing elapids to vipers. When meta-analyses group mechanistically different elements together just to bump up their sample size, it completely obscures clinical truths. And that right there is exactly what leads to that low certainty grade we saw at the very beginning of this explainer. Now, to be completely impartial here, it's vital to note that this Vibrown's framework is very transparent about its own limitations. The sampling is actually still being completed. They're moving from 12 to 78 case reports. It currently relies on single extractor AI assistance rather than having dual independent human reviewers. It lacks a pre-registered review protocol, and the evidence tiers are currently separate passes rather than being fully integrated just yet. So keep in mind, this is a draft. It's a transparent, source-traceable map, for sure, but it is not a final pooled consensus. But honestly, what an incredible map it is. By refusing to just average out all those messy outliers, Vibrown's shows us that the evidence for antivenom's life-saving power is very real. It's just heavily concentrated in the case reports because basic medical ethics prevent it from ever reaching the RCT tier. So I want to leave you with this final provocative thought to chew on today. If AI can map the shape of evidence like this, instead of just blinding us with averages, what other massive medical mysteries, obscured by forced consensus, are out there just waiting to be solved? Thanks for joining me on this deep dive today, and keep asking those tough questions about the data.